water, salt, and everything that's good. These were the ingredients chosen to create the perfect experiment. But Professor Tenorio accidentally added an extra ingredient, the X element. And that's how the super powerful plastic was born. Using its ultra superpowers, it turned into synthetic leather, plastic film, and polyvinyl chloride pipe, dedicating its life to making our daily lives easier and fighting the forces of evil. I think from the joke, you understood that today we're going to see how polyvinyl chloride is made, tested in the lab, and then brought to life in products we use every day. Shall we check it out? Polyvinyl chloride stands for polyvinyl chloride, and its production starts with chlorine. We've already shown how it's made right here at Unipar, which is located in Santo André in the metropolitan region of Sao Paulo. After the video, you asked us to explain more about polyvinyl chloride production. We returned to Unipar, the second largest polyvinyl chloride producer in South America, to see how this turns into this. First, remember, Unipar is a factory making raw materials for other companies. So many products come from this complex. I've already explained that in detail in the chlorine video, so you might remember that everything starts with a mixture of water and salt, the brine. It goes through several purification steps and then enters a chemical process that uses electricity to separate the atoms, something we call electrolysis. From H2O, you get hydrogen and hydroxyl, which is oxygen bonded to hydrogen. Salt or sodium chloride provides sodium and chlorine, which produce polyvinyl chloride. The chlorine comes here through these pipes in a gaseous form and will be mixed with element X. Yeah, element X is ethylene, which is a gas derived from petroleum. And with that, we get the basic recipe for polyvinyl chloride, which is water, salt, and ethylene. All of this will react at high temperature to form dichloroethane. Then, this molecule will be broken down. It will be cracked in the furnaces to produce vinyl chloride. Here, this substance is stored in liquid form inside these tanks. In chemistry, vinyl chloride works like a little piece, which we call a monomer. This mono comes from one. So imagine it's like a link in a chain, but when we put several links together and form a chain, we no longer have just one monomer. We have a polymer, which is a really big molecule. And that's where the name polyvinyl chloride comes from. Or, as we know it, polyvinyl chloride. At Unipar, they make two types of polyvinyl chloride. First, they put the ingredients into a reactor, and what comes out is a kind of slurry with small grains. This slurry will be centrifuged and then goes to a dryer. And that's how we get the dry resin, which is distributed to the customers. But polyvinyl chloride can also be produced in another way. And then they change the recipe by adding an emulsifier. The result of this is a latex, and then they filter and dry the latex until they get a resin in the form of a very fine powder. These resins must undergo quality control to ensure quality and classify them for potential use. A garden hose, for example, doesn't need to follow rules as strict as the resin that's going to be used in the manufacturing of a medicine package. One of the controls is the particle size, because each resin needs a different size. So the material is placed here in this machine, which will shoot a laser beam and measure the size of each little grain. Another important test is for contamination, because during drying, some polyvinyl chloride grains can burn. So this machine will take thousands of pictures and check if each particle is a little more brown or even black. There's also an analysis called fisheye, and it's done with the resin that has already been plasticized. What does that mean? To plasticize polyvinyl chloride means to add some additive to it, some kind of oil that will make the material plastic. And plastic, if you've never thought about it, means something that can be molded or shaped. So this test will check if there's any part of the material that didn't plasticize properly. This machine has a camera that can detect the little spots in the material that didn't plasticize. If a polyvinyl chloride with fish eyes were used to make a blister pack, which is that medicine packaging, for example, that would be a problem because the little holes would let air in and that could spoil the medicine. Finally, the moisture test remains. It's a problem because water can evaporate during plastic manufacturing and create bubbles. So here in the lab, they're going to use a super precise scale that heats up the resin. As expected, the weight drops as water evaporates, letting us determine the exact moisture content. Each client has a requirement and each market segment needs a specific resin. And Unipar produces raw materials for the sanitation, construction, and many other industries. Textile, food, footwear, beverages, pharmaceuticals, aluminum, paper, and more. Once approved, the polyvinyl chloride is sent to the industry in 25 kilogram bags, 1,250 kilogram bags, or in bulk by truck. Unipar doesn't make the final product sold in markets. In the lab, an area works with the technical market department to provide customers with technical support by testing products. The coolest part is they can simulate manufacturing here. Let's check it out. For example, this machine applies the coating. This is how synthetic leather is made, so a polyvinyl chloride paste is placed here. Below, there's a surface that mimics leather texture, and this is placed in an oven. When it comes out, we already have a fully flexible product with the texture ready. If you've never thought about how synthetic leather is made, I think it's worth leaving a like on this video, isn't it? This is the extruder. The polyvinyl chloride is placed at one end, then it moves along a screw, which heats and presses the plastic against the die, against an outlet, which is this hole. In this case, it has the shape of a very flat rectangle, so what comes out at the end is a strip. But if it had the shape of a ring, we would have a polyvinyl chloride tube here. If it was full of little holes like a shower head, we could have pellets, which are these plastics that look like dog food. In fact, there are intermediary industries that buy polyvinyl chloride powder to make the pellets and sell them to other factories that actually prefer to work with this type of material to make the final product. And it's in this process that plastic bags and plastic wrap are also made, the kind we use in the kitchen to cover food containers. They also have an injection molding machine here. The polyvinyl chloride is placed in this spot. It will be heated and pushed into a mold. The mold is shaped like the product. After pouring, let it cool and open it. And that's how the soles of shoes and pipe elbows are made. Polyvinyl chloride is a highly versatile material, and we haven't even shown all processing types. You could also see, for example, the calendaring process when the polyvinyl chloride resin passes through two heated rollers like making pasta dough. Or even rotational molding, the process used to make doll heads. The raw material is put in a rotating mold and sticks to its walls. When opened, the finished object is released. Polyvinyl chloride also becomes roofing tiles, hoses, boots, toys, and paneling. So now, the next time you hear about polyvinyl chloride, you won't just think about pipes. You'll remember that it's in a lot of things in your daily life, and that the raw material for most of these things came from here at Unipar. If you just landed here and haven't seen the video where we show how chlorine is made in this same factory, don't miss it. I'm leaving the recommendation here at the end.